It says that a researcher was interested in comparing, in comparing the students' performance in business mathematics and statistics. Okay, so we have business mathematics here, we have statistics. In order to determine the performance, he administered a quiz containing section A, which is business mathematics, and section B, which is statistics, and the maximum score for each section was 20 marks. Okay, so the results obtained were summarized in a frequency distribution table below. So what you're seeing here is we have marks in statistics and then marks in mathematics. Okay. You realize that this portion, the classes here are the same classes right there. This is more like a table that has been presented 2 in 1. Okay. However, here we have the marks in mathematics. These are the number of students, because they're telling us that this is a frequency distribution. So the marks are the classes 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. Those are the marks that were obtained. And now when they're telling us that this is a frequency distribution table, it means that for between people who earned 0 to 4 marks, here we have 1. Here we have 1 person. Okay, 0 to 4. That is for in statistics. Then those who earned 4 to 8, these are the marks in statistics. Okay, like that. I think you get the interpretation of the table. So what we are trying to mean here is the way this thing is structured. Marks in statistics, those who got 0 to 4, we have 1, 2, 3, 4. There are 4 people here. Okay, those who got between 4 to 8 marks in statistics, we have 4 plus 1, 5, that is 10, 11, 12. There are 12 people here. Those who got between 8 to 12 in statistics, we have, that is 6 plus 4 is 10, 12, 13, 14 people. Then those who got between 12 to 16, 3, 4, 6, that's 11 people. Then those who got 16 to 20 marks are 9 people. That is 5 plus 3, 8 plus 1, 9. That is as far as statistics marks are concerned. Okay. Then those who got marks in math. Okay. Those who got marks in math. Let me try and do this instead. Just to use different colors to avoid confusion. Okay, those who got marks in mathematics. The way this table has been structured, this for math and mathematics, those who got between 0 and 4 are 1, 2, 3, so there are 3. Those who got between 4 to 8 is 4, 5, 6, 7, 8 people. Those who got between 8 and 12 marks is 5, 9, 10, 11. These are 15 people. This is 6, 7, 8, 9. These are 14 people, and then these are 5, 10. 5 plus 3, 8, 9, 10. Like these are the classes. Those who got between 12 to 16, 16 to 20, these are the marks for math. Okay. Determine the section that had a higher spread of marks. Okay. Okay, up here I was just trying to summarize the table a bit. Determine the section which had better spread. Now, what parameter are we going to use to determine spread of marks? I think by better spread, which section had better spread? Now, by spread of marks, definitely here they are indirectly talking about which one, the marks that are spread. Let's say, let me try and explain this thing like this. So let's say we have, we have a bull's eye. Okay, darts. Okay, yeah, we do know darts. That is the bull's eye. You're trying to throw, arrows. Okay, and then as you're throwing arrows to the bull's eye, some arrows drop here, drop here, drop here, drop here, drop here, drop here. Then you can do the same thing. You have a bull's eye. You're trying to hit the middle target. This one is the middle target, but as you're trying to hit the middle target, as you're hitting, you're throwing your arrows, some drop here, others, another drops here, another drop here, others drop here, drop here. In other words, you're hitting far away from the target here. The targets here are closer, okay? Are closer to the targets. These ones are far apart. They are distributed. They are more spread. These ones are more spread. Okay, the targets here are more spread. Here, these ones are closer to the bull's eye. They are closer to the center. So what does that mean? This one that has more spread and this one are closer. How do we determine if we had this kind of in a statistical language? How do we determine the spread? We are going to determine the spread using a parameter called, we are going to call it standard deviation, okay? Okay. So if we are to calculate the standard deviation, it would mean that if we are to get the standard deviation of this and the standard deviation of that, it would mean this standard deviation here will be higher than this one. This one will be lower. Okay, if you're to compare the two, you'll find that maybe the standard deviation of this maybe, let's say, is 2. The standard deviation here maybe is 6. Now, the interpretation of this means that the standard deviation here shows that this is more spread. The results, the targets are more spread from the bull's eye compared to that. Or I think you get what I mean. The standard deviation is just the measure of just how much data is spread away from the mean. And so if you're to compare the two standard deviations, you're able to determine which one is more spread away from the mean from the other. So if you are to use that analogy, this is just an illustration. I'm just trying to help you understand the question. Here, when they come and tell you that determine which section has better spread of marks, I think by the word better, they mean which one is more, you know. Okay, what do we mean by better? Maybe they used the vague word here, better. Maybe they should have said determine which section had more spread or little spread, because better spread of marks, should we say better spread of marks means marks are supposed to be near each other? Or what is the definition of better spread? Does better spread mean they are far away from each other? I think the better spread means marks that are more far away from the mean mark. That is a better spread, okay? But in other words, what I'm trying to show you here is that when the interpretation of this is that standard deviation is the thing here. So we are going to look for the standard deviation to determine how marks are spread regarding statistics. Then we are going to find the standard deviation to determine how the marks are spread in mathematics. So we are going to compare those two standard deviations, and then we shall be able to determine which we shall be able to conclude according to the question here. The question says determine which section had better spread of marks. So I think here this word is really vague. They meant better. Maybe they should have just said bigger spread, okay? A bigger spread of marks or a wider spread, something like that. But anyway, we've gotten what the question requires, so let's get started. Now, when we are talking about statistical related numbers like these, normally there are formulas attached to them. Again, I am not going to go into the derivation of those formulas. Those will be top videos I'll do when we are covering the syllabus. Okay, so but in most examinations, you normally move into the examination room with they give you those formula booklets, and so when we come here, standard deviation, this is the formula for standard deviation. Okay, so you're just going to go and copy the formula, and you know, after copying the formula, you simply substitute. So the formula for standard deviation here, let me do it here. So, because we're going to look at the standard deviation for both. So the standard deviation is simply the square root of the variance. So the variance is given by summation of f of x squared, divide that by the summation of the f, which is the frequency, minus, in brackets, this minus the mean, okay? Summation of mean is f of x given by summation over f. In other words, total frequency times the variables divided by total frequency. This is squared, and of course all this thing is under a square root. Now it is going to be that, like, our columns, the columns that we are going to draw are going to be dictated by what is in our formula. So of course, as far as frequency distribution is concerned, we are going to get started with our classes, which are already here. Let's start with statistics, okay? Okay, statistics. So as we get started with our statistics class, we have our classes, and then we have our classes for statistics. We have our value of the value of x. Of course, we are getting the columns. What columns are we supposed to consider? We are supposed to consider the columns as we see them up here in the formula. So in the formula, we have our classes, our value of x, which I'm going to discuss later. Then we have our frequency, which is our value of f. Okay, that is our frequency. Then of course, if you look at this formula, we are going to need our x squared. So I'll come here. We are going to need x squared. We are going to need the product of f times x. Okay, let's get started with the thing for mean. We have f times x. F times x, we are going to need that figure. Then also we are going to need the value of x squared right there. So we're going to do that, x squared. Then also we are going to need f times x squared. Okay, so we are going to need also f times x squared, the summation, like that. So that is for statistics. Okay, so what are our classes here for statistics? We have 0 to 4 right there. Then we have 4 to 8. You realize that these ones are class boundaries. Again, those dynamics of class boundaries, by the time you are watching this video, I am assuming that these things were introduced to you. How we find the mean, what are class boundaries, what are class intervals, how we are going to get this value of x. Here we are just doing revision of something that was already introduced to you in class. If you're looking at these things for the first time without lessons, I think it is not wise. 8 to 12, some of these things need to be introduced to you so that you understand where they come from. And that is something that I'm not going to do in this revision series. That is 12 to 16 is another class. Okay, then 16 to 20. Like that. So those are our classes right there. Okay, and we are going to be drawing our totals down here like that. So that is as far as statistics is concerned. Okay, so let's do for mathematics as well, and then we just start filling in figures. So because we want to find we need to find these things. Okay, so let's do this for maths. Okay, so because mathematics, let me do this here. Okay, so mathematics, let's do our table for mathematics here. It's going to be pretty much the same as this one. So we begin with our classes. Okay, then we have our value of x. Okay, then we have our value, the frequency, f times x. We are doing f times x because it's required in the formula up here, f times x. Okay, then we shall also do x squared because it's in the formula. Then we also need f times x squared, like that. Then of course our classes here have 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. And of course here also we have we shall be doing our formulas, our totals down there. Okay, so those are the two tables. So after determining our columns, we have determined our columns from our formula up here, what we need. So let's get started. So determining our value of x here is going to determine how we'd find it. It's going to determine whether we've been given class boundaries and class limits. I think again you must be knowing the difference. This what ends here is what starts here. 4 to 8, the last digit here is the first digit here. So these ones are class boundaries. But then there's such a thing we call class limits. If we are having class limits, you know, the upper class limit and the lower class limit, the way we get the value of x here will be different from when it is what? It is class boundaries. It's different. I will not go into those details now. So let's get started. So what we do here, we are simply going to, there are many ways of getting it. We can say the upper class boundary minus the lower class boundary divided by 2. And we add the answer to the lower class boundary. So it is 4 minus 0, which is 0. 4 minus 0, which is 4, divided by 2, it's 2. So we add the 2 to the lower class boundary, which gives us our value of x here as 2. Same here, 8 minus 4 is 4. What is 4 divided by 2? It is 2. We add the 2 to the lower class boundary, so 4 plus 2, which is 6. Come here, 12 minus 8 is 4. So 12 minus 8 is 4. What is that? 4 divided by 2, you get 2. So we add the 2 to the 8. We end up with 10. Come down here, 16 minus 12 is 4. What is 4 divided by 2? That is going to give us 2. We add the 2 to the lower class boundary here. 12 plus 2, which is giving us 14. 20 minus 16 is 4. What is 4 divided by 2? It is 2. So 2 plus the lower class boundary here, it's going to be what? 18. So those are our values of x right there. And of course our values of x here, it's going to be the same here. 2, 6, 10, 14, 18. Now these ones are classes that have the class intervals are the same. Okay? And again, the approach is different when we are dealing with class limits. If we had class limits instead of class boundaries, we will discuss that later on. Okay, so now let's look at the frequency. So between 0 and 4, how many here for statistics? So let's get back to our table up here and start filling it here very fast. So for statistics, remember our statistics are these ones here. So between 0 and 4, I think we had already done them here. We have 4, 12, 14, that and that. Okay, we had already added the number of students. For those that got between 0 and 4, the number of students are 2, 3, 4. They are already 4. We had already done that in the beginning. So we could as well say these ones are 4, okay, for statistics. Then these ones are 12 right here. Those ones between 4 to 8, if you are to add up these ones, they are 12. So that is 12. Between 8 and 12, they are 14. So these are 14. So like that, 14, 11, 9. Okay, 11, 9. I hope I've not left anyone behind. Those are the frequencies. Okay. Can we do the same for math? We're doing these things concurrently. And this is information we are picking from the table. So for mathematics, those are between 0 and 4. If you come here, up here, those between 0 and 4, they are 3. We already added them here. They are 3. So we shall come here, 0 and 4. We do 3. Then those between 4 and 8, for maths and mathematics, we added them here, 4, 5, 6, 7, 8. We already added it here as 8. So we shall come here, and these ones are 8. So the same here, 8 to 12, they are 15. So we come down here and say they are 15. Okay, so the rest is going to be, then they are 14, then they are 10. The ones for 12 to 16, they are 14. These ones are 10, like that. So we have, those are, but basically we have just copied the frequency tables for statistics and mathematics. So now the rest of the work is just computational. We are trying to compute what is f times x. So here we do calculator business to fill in the remaining tables. Okay, so f 4 times 2 here is 8. Okay, that is as far as we are dealing at the statistics. 6 times 12 is 72. Then this is going to be 14 times 10 is 140. Then, because this is f and x, 11 times 14 is 154. Then this is 162. X squared, we are looking at 2 squared. X squared here is 4. This is 36. This is 100. That is 10 squared. Then 14 squared is 196. Then definitely here we have 18 squared, which is 324. It's very easy for you to make an error. Here it is very important that you tread carefully. You fill in these things carefully. It's very easy to make an arithmetic error as you're punching in your calculator. So fx squared, so we are getting our column of f, and we are multiplying it by x squared. So here it's 4 times 4, which is 16. Then here we have our f, which is 12 times 36, which is 432. Okay, then we have f times x squared, 14 times 100, which is 1400. Then we have 11 times 196. 11 times 196 giving us 2156. Then of course lastly, this is going to be our f, which is 9 times x squared, which is 324, is going to give us 2916, like that. Okay, so basically it's just arithmetic. So we're going to do the same for this mathematics thing here. Okay, so again, I'm just going to do this faster. I think we all get what we do. So again, remember, now we finished filling in all the tables. Remember, when we are trying to find the totals, of course, our totals here are going to be determined by our formula. So in our formula for standard deviation, we are going to need summation of f, f of x squared, as you see here, f of x squared, which is this thing here. Okay, we need the summation of f of x squared, so we are going to need that total. So we are going to go ahead and add it. F of x squared here, for statistics, it's going to be 6,920 after adding this column. That is summation of then we have summation of f, which is right here. And what is summation of f? It is 50. This is our summation of f. So we're going to need also summation of fx, summation of fx here. When we add our summation of fx here, we are going to end up with 536. This is our summation of fx right there. Then what else? Yeah, that's it. So we are going to do the same totals this way. Okay, here in our value of x, a summation of f, definitely it's already 50 here. Okay, Then this is going to summation of f of x. Our summation of f of x here is 580. Then we have our summation of fx squared right there. It's going to give us 7,784, like that. This is summation of fx squared. Yep, like that. So I think we have it. So now we can go ahead and find the standard deviations for both, okay, statistics and mathematics. It's now that we have put the things in our formulas, it's a matter of just, substitution, and we get our answers. Okay, so our standard deviation for statistics, of course, it's going to be summation of f of x squared over the summation of the frequency minus the mean squared, okay, minus the mean squared under the square root. So what do we have here? What we have here is going to become under the square root. Of course, what is f of this summation of f of x squared is this up here. So we're just substituting figures here, right? So this is going to become 6,920. Divide that by summation of f, which is 50, minus the mean squared. This is going to be 536. Divide that by 50. Summation of f of x here is 536. Then summation of f is 50 squared. So what do we have at the end of the day? All this is under the square root. Of course, if you punch that into your calculator, you're going to end up with 4.8458. Like that. That is as far as standard deviation for statistics is concerned. Now let's do standard deviation. Okay, standard deviation for math. So for standard deviation for math, again, we are going to substitute into that formula. Summation of f of x squared, divide that by summation of f minus the mean squared, which is summation of f of x over summation of f. Okay, so what do we have here? Summation of f of x squared. If you come here, up here on our table here, it's going to be this 7,000, this summation of f of x squared, so it is 7,784. Divide that by summation of f, which is up here, which is just 50, minus the mean squared. The mean here is summation of f of x, which is 580 right there. 580, divide that by summation of f, which is 50. This is squared, and this whole thing is under the square root. So what we end up here is 4.5957. So after ending up with that, then you let's get back to the question. We have found the two, the standard deviations of the two. So which one has a better spread? So you will find that standard deviation for statistics is 4.8. Okay, the one for math is 4.5. So this one has a higher spread. In other words, this figure 4.8, it's just giving us the measure to which this data is spread away from the mean. Okay, so if you come back up to they're asking us determine which section has better spread. Of course, here the one that has better spread is statistics. So we shall conclude and say that statistics the data that has the statistics. Okay, which section has better spread of marks? The statistics marks have a better spread. So that's how we shall conclude. We shall simply say statistics marks have a better, they have a better spread. So that's it.